Welcome to the session on differentiation, the chain rule. The objectives for this session are to differentiate functions using the chain rule. Composite functions, or functions of another function, can be differentiated using the chain rule. dy dx equals dy du times du dx, where y is a function of u and u is another function of x. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solution. In this example, given that y equals 3 minus 2x cubed, all raised to the power minus 5, find dy dx using the chain rule. So let's solve this. So we have this expression for y. And we let u equal the bit in the brackets, as shown here. So u equals 3 minus 2x cubed. We can differentiate this with respect to x to give du dx equals minus 6x squared. We can also rewrite y as y equals u to the power minus 5. And therefore dy du equals minus 5 times u to the power minus 6. We can now plug in du dx and dy du into the formula for the chain rule, as shown here. So we have this expression for dy dx. However, u is a variable which we have introduced, and therefore we must now replace it with the expression we originally had for u. So we have, tidying up, minus 5 times minus 6, which is 30, x squared, which stays as it is, and u becomes 3 minus 2x cubed. And of course, the u is raised to the power minus 6. And so we have our expression for dy dx. Let's now take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. In this example, we're required to find dy dx using the chain rule, given that y equals sin x plus cos x, all cubed. So let's solve this. So here's y. We're going to let u equal cos x plus sin x, so the bit in brackets. U can be easily differentiated now. Cos x differentiates to minus sin x, and sin x differentiates to cos x, to give us this expression for du dx. We can also express y as y equals u cubed, and then differentiate to give dy du equals 3u squared. And now we can plug in these expressions into the formula for the chain rule to give dy dx equals 3u squared times cos x minus sin x. However, notice that u was an expression which we introduced, so we must again replace this with cos x plus sin x, as shown here, to give this expression for dy dx. We can write the chain rule using function notation. Remember that the chain rule allows us to differentiate a function of a function. So in general, y equals f of x all raised to the power n implies dy dx equals n times f of x to the power n minus 1 times f dashed of x, and y equals f of g of x implies dy dx equals f dash of g of x times g dash of x. Let's now apply these rules to an example. Pause the video and have a go. Press play when you're ready to view the solution. So in this example, we're required to find dy dx at the point 1, 1 over 25 for y equals 1 over 4x plus 1 all raised to the power 2. So let's solve this. We can rewrite y as 4x plus 1 all raised to the power minus 2. We can let g of x equal 4x plus 1 and f of x equal x to the minus 2, using the notation on the left-hand side of the screen. So we have that y equals f of g of x. And from this, we can deduce that g dash of x equals 4. The chain rule tells us that y equals f of g of x implies dy dx equals f dash of g of x times g dash of x. So we have dy dx equals minus 2 times g of x to the minus 3. Since we're differentiating g of x all raised to the minus 2, notice that we're looking for f dash of g of x. And this is of course multiplied by g dash of x, which is equal to 4 in our example. Tidying up gives us minus 8 times 4x plus 1 to the power minus 3. And so we have dy dx. At the point 1, 1 over 25, we need to find the value of dy dx. So we can plug in x equals 1 into our equation for dy dx, as shown here, to give us dy dx equals minus 8 over 125. There is an alternative solution to this problem. Let's explore this. We can rewrite y as 4x plus 1 all raised to the power minus 2. So let f of x equal 4x plus 1, and so f dash of x equals 4. We also have that y equals f of x to the minus 2. Now the other form of the chain rule states that y equals f of x raised to the power n implies dy dx equals n times f of x raised to the power n minus 1 times f dash of x. So plugging in the relevant expressions gives us an expression for dy dx. We plug in n equals -2 here. We plug in f of x here as shown. And we plug in f dash of x equals 4 here. And so we have this expression for dy dx. And of course we can tidy this up. -2 times 4 is -8. 4x plus 1 is here. And -2 minus 1 is -3. And therefore dy dx equals -8 times 4x plus 1 raised to the -3. Now at x equals 1, we can plug in the value of x equals 1 into this expression. To give us again the value dy dx at x equals 1 equals -8 over 125. We can re-express the chain rule again. For functions which are not in the form y equals f of x, we can rewrite the chain rule as dy dx equals 1 over dx dy. Let's use this in our next example. Pause the video and have a go. Press play when you're ready to view the solution. In this example, we're required to find the value of dy dx at the point 26 over 5, 25 on the curve with equation y to the power 1/2 plus y to the power -1/2 equals x. So let's solve this. We're going to find dx dy. Since the function is expressed as x equals a function of y. So we have dx dy equals 1/2 y to the power -1/2 minus 1/2 times y to the power -3 over 2. And therefore dy dx is equal to 1 over dx dy, which is 1 over this expression as shown here. If we multiply the numerator and the denominator by 2y to the power 3 over 2, we have a much neater expression as shown here. We are trying to find the value of dy dx at the point 26 over 5, 25. So we need to plug in the value y equals 25 into the expression for dy dx as shown here. And tidying this up gives us a neater numerator. And tidying up some more, we have root 25 to the power 3 divided by 12. Root 25 is of course 5, and this is raised to the power 3. So we have dy dx equals 125 over 12 at the point 26 over 5, 25. And this tidies up to 10 and 5/12. This brings us to the end of this session. If you have understood its contents, you should be able to differentiate functions using the chain rule. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.